Okay, I want to introduce valence electrons. Now, we're not going to go in great depth. We're not going to look at electron configurations and the foundation of valence electrons. What we're going to do is just talk about kind of the basic idea of what is a valence electron and how do you determine how many valence electrons something has. So first off, valence electrons really are just the outermost electrons in an atom. Okay. And when I say outermost electrons in an atom, another way it can be described is the outermost principal energy level. And so electrons within an atom, although they're all outside of the nucleus, they do have different energies. So when you have lots and lots of electrons in an atom, some of them have lower energy than others. And so some are in higher energy levels, and the higher the energy level would be considered further out. And less, essentially, those electrons are kind of less stable. And so those actually are held most loosely. Okay, so the electron isn't, or the atom isn't hanging on to those as tightly, meaning it's really more willing to kind of either give them up or share them. So those are the actual electrons available for chemical bonding. Okay, so those are really important when you're trying to understand the structure of things, so how things bond, and essentially once you know how they bond, also how then this structure is going to be oriented, and so then what the shape of it is and how then it behaves macroscopically. And so, you know, valence electrons is the foundation of a lot of stuff. If we understand, you know, our valence electrons or can determine how many, we can do a lot with that. Okay, so those are the electrons that are kind of the foundation of what we talk about in general chemistry when we're talking about chemical reactions. Now, these are the things, well, as I was just saying, they're responsible for our chemical reactions or our chemical properties. So they control why something actually, or they control whether or not something reacts with something else. Okay, is those valence electrons. They either allow it to react or don't because of what electrons are there, kind of what energies they are, and what's going to happen to them if they do interact. Now, the last point I want to talk about is how do you determine how many valence electrons a particular atom has? Well, we're just going to look at the basics of it, and you really, for representative elements or main group elements, it's tied directly to the group in the periodic table. Okay, so which group they're in. If they're in group 1 or an alkali metal, all of those things have one valence electron. If it's in group 2 or is an alkaline earth metal, they all have 2 valence electrons. Okay, and then the third group has 3, the fourth has 4, and so on, all the way over to the noble gases, which have 8 valence electrons. Okay, although 8 is kind of a stable situation. If something has 8 valence electrons, it's pretty happy where it's at. That's why noble gases don't actually participate in bonding very often. So they don't really react with things very often. Now, there are some scenarios where it happens, but in general, it's not very favorable because they're already kind of in this stable situation where they have 8 valence electrons. So when you start looking at bonding, most of the time when you get started, what you're looking for is an octet of electrons, and so that's what that is. You're looking for obtaining 8 valence electrons, because anything that doesn't have 8 valence electrons, at least in some sense, is a little bit unstable. Okay, although I notice now there's a little bit of a error on this table that I didn't catch before. This says 8 for helium. Helium's actually got 2 because it's only got 2 electrons altogether. So hydrogen and helium are kind of oddballs in all of this. So hydrogen has one valence electron, helium has two. Neither one of them ever has any hope to get to 8, so they don't even try. And so kind of 2's their magic number. Now, all those others, the transition metals and the intertransition metals that aren't labeled here, those, the valence electron situation is a little more complicated. In a general sense, when you're kind of just talking about the very basics of it, we usually say they all just have 2, okay? But it is more complicated than that. So you need to focus on main group elements because that's where you'd always start when you're talking about bonding.